So welcome to this virtual JuMP-dev. If you haven't met me, my name is Oscar and I'm one of the core contributors to JuMP. And this talk is really on the state of JuMP, where we are and where we're going. And I'd like to start by first thanking the JuliaCon organizing committee for helping us co-locate JuMP-dev as a track of JuliaCon. They've been most helpful in that. So if you're just joining this talk and you don't necessarily know what JuMP is, I thought I'd start by kind of introducing everyone to JuMP. JuMP is a few things. It's a package in Julia, JuMP.jl, but it's a few other things as well. It's a GitHub organization, JuMP-dev. It's also a website, JuMP.dev. And in the GitHub organization, we have something like 42 repositories. And the reason we have all of these repositories is that it is our mission to provide a free open source software stack for mathematical optimization. And that's based on this thing called the JuMP modeling language, which is a nice user-friendly API that's implemented in the JuMP.jl package. And by mathematical optimization, we're really talking about constrained mathematical programming. So instead of just having some black box function that we want to minimize, say using optim.jl, JuMP isn't really for that. It's really for mathematical programming where we have decision variables, an objective function, and some constraints. And so if you have that type of problem, then JuMP's for you. It's for things like linear programming or mixed integer linear programming, conic programming, or nonlinear programming. In terms of what's actually in the JuMP-dev GitHub organization, there are two main packages. There is this JuMP.jl and there's this mathoptinterface.jl. So I went to juliahub.com for these statistics. And so JuMP is the kind of main package that users will interact with. And this implements a modeling language that allows them to write down mathematical optimization problems. And then underneath JuMP sits this mathopt interface, which is an abstraction layer which helps turn the user-friendly model that people wrote down in JuMP into something that solvers can understand on the back end. Both of these packages are quite widely used throughout the Julia ecosystem. So in Julia Hub, you can look at how many other packages in the Julia registry depend on your package. And so there are 158 packages in general which use JuMP as a dependency, and there are 263 packages which use mathoptinterface as a dependency. And so JuMP is bigger than just the JuMP-dev GitHub organization. There are lots of packages throughout the Julia ecosystem that use JuMP. And we're going to hear from a number of those developers throughout the rest of these talks in this JuMP-dev. We also have to thank a lot of people for working on JuMP over the years. When I took that screenshot, there were 113 people who had contributed to JuMP, and 49 people had contributed to mathoptinterface. And so we need to thank all of those people for their hard work. Another thing of JuMP that we've tried to do over the years is host these JuMP-dev workshops. We've had 3 so far. We had one in Cambridge in 2017. We had one in Bordeaux, France in 2018. And then the last JuMP-dev workshop we had was in Santiago, Chile in 2019. So it's been a while since we last had one of these workshops, and I'm pleased that we're finally getting back into it. So broader than the Julia ecosystem, where is JuMP used? Well, if you use JuMP in academia, you can help us by citing this paper, JuMP, a modeling language for mathematical optimization. And the last time I checked, this had been cited by over 800 people. JuMP is also a NumFocus project. It's a fiscally sponsored project at NumFocus. And if you don't know what NumFocus are, you can go to numfocus.org. They're an umbrella organization for scientific computing projects. And other NumFocus projects are Julia, SciML, and then a whole host of Python projects like NumPy and SciPy and Pandas. You can also help us by starring JuMP on GitHub. So if you go to the GitHub link down below, you can click star in the top right corner. At the moment, we have 1,500 stars, and so if you use JuMP and you like it and you haven't yet gone and done that, you can help us by doing that. It's one of the metrics we look at over time to see how JuMP is growing. JuMP is also used in industry. So in one of these Julia computing case studies is a Brazilian company, PSR, which do research into power systems, and they use JuMP to solve very large optimization problems, looking at how we can efficiently use renewable energies, such as that from hydroelectric turbines. Also, if you're getting into JuMP and you don't know where to start, you should look up this book, Julia Programming for Operations Research. It's a good introduction to JuMP and it has a lot of problems that get worked through to show how you can solve problems using JuMP. Okay, so that was a very brief introduction to JuMP. What are we going to talk about in the remainder of this time we have left? Well, we're going to talk about some of the talks that are going to coming up in this JuMP-dev. We're going to go over some of the governance changes that have happened in the last couple of years since our JuMP-dev in Santiago. We'll go through some recent additions to the code base, and then we'll talk about the roadmap to JuMP 1.0, even though we've been talking about this for a long time now, we're very close, and we'll conclude with some plans for the future of JuMP. So I took a look at the talks that are coming up over the next 3 days in this JuMP-dev, and there are kind of around 30 talks that are going to be taking place. And I've tried to group them into these kind of 6 key themes of conic programming. So we have talks on solvers like Cosmo.jl and Hypatia, which are new pure Julia conic solvers. There are some talks on JuMP extensions, things like bi-level JuMP for solving bi-level programs and infinite opt for solving problems with infinite dimensional variables such as integrals and stuff like that. There's also a few talks on constraint programming. And here I need to pause and say that in the past at JuMP-dev we have a tradition of inviting speakers from modeling languages other than JuMP and Julia to talk about their experiences. And this year I'm very pleased to invite Gleb Belov from Monash University in Australia, who's going to be telling us about the Minizinc modeling language. And I'm kind of very interested to hear some of the design decisions they went through and how we can incorporate some of those into JuMP. Another big theme of the talks in this workshop is on nonlinear programming. We have some new solvers and some new attempts to hook up external nonlinear solvers into JuMP. There are also some talks on applications. So we have things on energy and some on milk supply in New Zealand. And you can probably tell from the accent that that's something very close to my heart. And then the final group of talks are on this thing that I call variations of linear programming. And there is really just a mix of talks on linear and mixed integer linear programming. There are some new solvers and some new tools around that. So into some of the main changes that have happened recently. The first thing is we've formalized how we make decisions in JuMP. And you can read more about this by going to the governance page on the JuMP.dev website. And the first thing is we have appointed a benevolent dictator for life of Dr. Miles Lubin, who's one of the founders of JuMP. And for those of you who are new to open source, this term benevolent dictator for life is often used when we appoint someone who is the final authority in any kind of decisions that get to be made. And we hope that Miles is a benevolent dictator for us. There are also 2 main groups that get to make decisions in JuMP. There is a group of core contributors which make code-related decisions, and then there is this steering committee which helps us with our interactions with non-focus. On the core contributor side, these people have admin access to all of the JuMP-dev GitHub repositories. They're also helped by some repository maintainers, and these repository maintainers help us maintain 1 or 2 repositories in the JuMP-dev GitHub organization. This group of people is not static. If you want to help us make JuMP better, we'd love to have you. And go and read the governance doc, which explains how you can help and how you can become a repository maintainer and how you can transition from a repository maintainer into a core contributor. As I said before, the steering committee helps us with our relationship with non-focus, and the main job of this group is to make financial related decisions. So if you donate money to JuMP, it gets donated not to us directly, but to non-focus, and then the steering committee gets to decide how we spend those funds. And I bring up funding because we are very excited to announce that we have some funding from the National Science Foundation to work on the maintenance and support of JuMP in the long term. At the moment, this funds me to work on JuMP for 3 days a week, and it's renewable until the end of 2023. So what are we going to use this funding for? We're aware that it's a big step to go from having no funding to some funding. And so the things that we're going to use this funding for are really to address some of the boring maintenance issues that have long gone unaddressed in JuMP. And this is things like fixing old GitHub issues that have been open for a long time and not fixed, to improve some of the code health and reducing some of our tech debt. So I've been spending a lot of time recently fixing how or redoing how we can test solvers through MathOp interface, improving the documentation, and improving error messages. And these are things that are kind of necessary to make sure that JuMP stays well maintained and active, but it's not that fun if you're a volunteer contributor working on it in your weekends. You'd rather be implementing shiny new things. And so the idea of the funding is to do the boring back-end stuff in order to free up time for our volunteers to do more exciting things. The other things that are covered by this funding are maintaining some of the open source solvers. It's worth pointing out here that this means open source. The commercial solvers are not covered, so the funding doesn't cover maintaining things like Arobi or Cplex or Express. And if you use those solvers, we'd really like you to reach out to those companies and let them know that you would be interested in commercial support for Julia. The other thing that this funding is going to address is helping get new members contributing to JuMP via helping people make PRs and making sure that their contributions are reviewed promptly, and also doing things like improving the documentation and the workflows and the testing of how and to make it easier to contribute to JuMP. The other thing that's not covered is kind of new specific feature requests. So if you have a feature request for JuMP, you can't open an issue and say, I want this done by Oscar tomorrow. That's not really going to happen. Speaking of kind of new feature requests, here's the JuMP 1.0 roadmap. So when we had our last JuMP-dev in Santiago, Chile, we came up with a list of things we wanted done before we would be ready to release JuMP 1.0. It's available at this link. And I'm now very pleased to announce that all of these items are now done. And so I'd like to go to the documentation and walk through some of the changes that have happened recently. So now we'll switch to this documentation. One of the first things we did was create a new website for JuMP, and that website is now available at JuMP.dev. And this is also the easiest way to get to the JuMP documentation if you go to JuMP.dev and then you click the documentation tab. There's also this governance tab, as well as some things like the link to this 2021 workshop and our blog. But if we go to the JuMP documentation, we'll have a look around. So one of the things I've been spending a lot of time recently is on updating a lot of this documentation. And one of the things I did was add some of our integrated tutorials, which used to live in the JuMP tutorials repository. They're now built into the documentation. And one of my favorite tutorials is the Space Shuttle reentry trajectory, which goes through and solves a nonlinear optimal control problem to figure out how a space shuttle should re-enter the atmosphere. And so these tutorials can now have math in them. They can have the algebraic equations that we're solving. We can have some of the data that we're using. We can add pictures, and then you can have the code. So here we define a lot of constants. We go through and we define some of our variables, which are things like the altitude and the longitude and latitude of our space shuttle as it's coming into land. We can define things like nonlinear expressions and nonlinear constraints, and then we can optimize and we can plot the solution. And as the space shuttle is coming in, here's the latitude and the longitude, and this is its altitude. You can kind of see it's coming in and doing this kind of bouncing pattern as it comes into land. There are a few other tutorials to look out for. If you go to the Getting Started page and then Getting Started with Julia, if you're a new user to JuMP, this is where you should probably start. This goes through and explains different bits of Julia, things like dictionaries and loops and control flow. And you can also read this Getting Started with JuMP, which goes through how to install JuMP, and then a simple example and what the different bits of code mean. I'll also point out this performance tips tutorial. So we get a lot of comments of people that come to JuMP and Julia expecting it to be fast, and then they write a model and it's slower than they expect. You should come and read these performance tips. And in particular, you should go and read the performance tips section of the Julia manual, which is very good in helping you write better Julia code. Another common request from people is how to work with data in Julia and JuMP. So you can read this Working with Data Files tutorial, which goes through on how to use the data frames package to read in data from CSV or Excel files and work that into a JuMP model. And it ends with this modeling example of the passport problem, which says what is the minimum number of passports we need to visit every country in the world without needing a visa. Okay, so this reads in some data from a CSV, and then it goes through and it builds a jump model and optimizes that to find the solution. I've also made sure to clean up a lot of our section of the manual. And the manual is really a collection of how-to guides. So it's things like how to set a linear objective and how to set a quadratic objective. And now these should all have short kind of code snippets that you can copy and paste. Now to talk about some of the kind of new features that have been added to JuMP. Most of them are on this solutions page. And one of the cool things is this solution summary function, which was added quite recently. And the idea is that after you have solved a model, you can call solution summary to print out some of the summary statistics about that model. It says whether the status was optimal or unfeasible, whether you found a feasible point for the primal and the dual, what the message is from the solver, what the candidate solution is, and then some work counters like how long it took to solve or how many simplex iterations it took. There's also this verbose argument, which will in addition print out the primal and the dual solution for the variables and constraints. Although if you have a very large model with kind of thousands or tens of thousands of variables and constraints, you probably don't want to be doing this because it'll print out 10,000 lines. Another key thing that we've added that has been a long request is to find infeasibility conflicts. And so this is often useful when you have a model and you solve it and the solver reports that it's infeasible and debugging that. So there's a thing called the irreducible infeasible subsystem, or the IIS. And so some solvers support finding this. And it's basically this minimum set of variables and constraints that you need that will still result in an infeasible problem. And the way to find the irreducible infeasible subset is to call this compute conflict function. And then there is a copy conflict function that you can use, which will return a new model that contains that minimal subset of variables and constraints. And then you can use write to file to write that out to an LP file or something to aid your debugging. Another recent addition is the ability to return multiple solutions from a model. So some solvers like Garogi will support returning multiple primal solutions. Say when they're solving a MIP, they will return all of the feasible MIP solutions they found. And the way to access multiple solutions from a solver is to first check how many solutions the solver found using result count. This will be from 1 through to n, say. And then you can access each of the solutions by using the result keyword to functions like value and objective value. Now it's worth pointing out here that only the first solution is guaranteed to be optimal if the termination status was optimal. The other results may be suboptimal, and you can check if a solution is suboptimal by comparing it to the objective value of the first solution. Another kind of long-held request is the ability to check the feasibility of a problem. So often people have a model and then they have a point that maybe they've found by some heuristic, and they want to say, does this point satisfy primal feasibility? And now you can call this primal feasibility report, which takes in a model, and it takes in a dictionary which maps variables to their values, and then it returns a dictionary which maps constraints to the amount that that constraint is violated by. Now, if the point is feasible, then the dictionary is returned with 0 entries. So those are a few of the new things that have been added to JuMP. And we're very close to a JuMP 1.0 release. So if we look at our roadmap, these are now all been done. We've done how to check the feasibility of solutions, the IIS, multiple solutions, and there's a few other things we've done. We've made the documentation better, we've improved some of our unit tests, and we've added new packages like Bondman and Cooling. But coming back to the slides, if we talk about what the roadmap now is to JuMP 1.0, you can read more about this in this issue 2564. But really, we're very close, and there's going to be a couple of things that need to happen before JuMP 1.0. We're going to make one breaking release to MathOpt interface and release 0.10. Then we're going to go through and make breaking releases to all of the solvers to update them to MLI 0.10. Then we're going to make one breaking release of JuMP to 0.22, which will update JuMP to MathOpt interface 0.10. And then just like the transition from Julia 0.7 to 1.0, effectively the 1.0 releases of MathOpt interface and JuMP will be those releases just with some deprecation warnings removed. So once we've updated JuMP, we can then immediately release method interface 1.0, update all of the solvers to 1.0, and then release JuMP 1.0. So I just said that we're going to be making a breaking release to method interface and to JuMP, and that might have you worried, but don't worry too much. On the method interface side, there will be a lot of breaking changes for users that are using it directly, but most of these are just renaming. So we've tried to go through and make sure that all of the names we use for functions and types are consistent. I said at the start that I'd already also been doing a lot of work overhauling how we test solvers in method interface, and so the MOI.test submodule that has done a big change, and there'll also be some other changes to how the caching optimizer works. But this will only impact you if you use method interface directly. And mainly this is going to be people that are writing solver interfaces. So for you, yes, there are going to be some breaking changes, but they're mostly just find and replace. There's very few actual changes that are going to require a lot of work. And on the JuMP side of things, this should impact very few users. It's really only going to impact you if you access the back end of a JuMP model, and then you do things with that. So if you've ever called back end of model and then gone back end of model.model.optimizer and so on, this may change for you, and so that's just something to be aware of. But other than that, nothing really is going to change. None of the macro syntax is going to change, and models that you write today in JuMP, assuming you don't call back end of model, should continue to work in JuMP 0.22 and in JuMP 1.0. So once we release JuMP 1.0, what are the things on our agenda? There are really three main things, or one main thing and two other things. The biggest thing is to rewrite JuMP's nonlinear interface. So there are a few problems with the current design. You have to call @nl objective and @nl constraint instead of @objective and @constraint. You can't do things like delete a nonlinear constraint. You have to rebuild the whole problem. And the way that we do automatic differentiation of problems in JuMP is very specific to JuMP. At the moment, we use an internal AD engine called reverse diff sparse, and we don't take advantage of a lot of the other changes that have been going on in the Julia world, like chain rules. And so we want to kind of totally rethink how we do nonlinear in JuMP. But again, most of this is going to happen on the back end. There may be some changes for users, like switching from @nl constraint to @constraint, but hopefully we can try and minimize the kind of user visible changes in that, and most of the work is going to happen for that behind the scenes. And that's going to be a very big piece of work that's going to take a long time to do. There are two other things that are on our kind of list of things to do post JuMP 1.0. One of them is multi-objective support. So at the moment, JuMP can only solve scalar-valued objective functions. We'd like to extend that to vector-valued objective functions, so we can do things like multi-objective optimization. And then the other thing, I've invited Claire Beloff to talk about Minizinc because we're really interested in extending JuMP to have better constraint programming support. And that's on our list of things to do as well. So while we're kind of wrapping up here, how can you get involved in JuMP? There are a few ways. You can go to the community forum if you have questions on how to use JuMP. If you have time, you can also go there and help answer other people's questions, which is also very useful. If you want to talk to some of the core developers, you can join this developer chat room. If you're writing new solvers or packages which extend JuMP, here's the best place to come and ask questions. If you have time, you can help us by contributing code or improving the documentation. You can do that by going to github.com/JuMP-dev. We organize how we contribute code and what things we're kind of working on over the next month at the monthly developer call, which is a Zoom call that's held on the fourth Thursday of every month at 2 p.m. Eastern. If you want to come to that call, you're welcome. You can ask for an invite by coming to the developer chat room and saying, hey, I want an invite to the monthly developer call. And anyone is welcome, and if you have something you'd like to discuss, you can put it on the agenda. The other thing that we'd like people to do is that if they do cool things with JuMP is to tell us about them. One way to tell us about them is at these JuMP-dev workshops. I want to thank the 30 or so speakers that are going to be talking over the next 3 days. I hope that maybe next year, once this pandemic thing is over, we can host a JuMP-dev in person, and maybe since right now this is probably sometime in the middle of the night for me, hopefully we can host that in the southern hemisphere somewhere. And the last way you can help JuMP is by donating and going to numpfocus.org. And with that, I'd like to thank everyone for coming to this virtual JuMP-dev, and thanks to all of the speakers over the next 3 days for helping make this a success.